Hello everyone. Hello. I think let me check my voice first. I think yeah. Okay. So welcome back to Let's Crack JEE in English. I'm Jeetendra Dixit. I did my BTech from IIT Kanpur. So this is my profile. I've been mentoring IIT-JEE aspirants for last 11 years to excel in mathematics, and we were discussing calculus. So today we'll discuss standard limits. Okay. So I'll tell you all these standard forms which we can directly apply, which we can directly use, okay, in detail. So that's a very important portion of limits. But before we start, let's discuss about Unacademy's platform. So as you know, it is India's largest online learning platform. And once you get the admission, once you get the subscription for Plus or Iconic, okay, so you can have Plus subscription or Iconic subscription, and how much you would have to pay and what are the things you will get. I'll explain all those things. So first of all, once you get Plus subscription, Plus, so you will get the access to all the educators who are teaching for IIT-JEE. All means all physics, chemistry, and maths. All right. So India's top educators are teaching there. You will get access to all those educators. You can access their course. You can attend their live sessions. You can watch their offline videos offline also by downloading them. Or during the live sessions, you can ask your doubts also. You can participate in polls. So these live sessions are very interactive. And even if you don't have the Plus subscription, then you can attend special classes, all right, on the platform. So just download the app, make your account, and start attending special classes. These live special classes are taken by all the educators. Every day there are lots of special classes going on, so you can attend those classes. You can learn there also, and you'll get to know the feel of the platform. All right. Apart from these live classes, you also get tests and quizzes, all India test series and quizzes. You will get access to all these tests, and all the courses which I'm telling you are uh, well structured. That means everything is pre-planned. You can see the schedule of all the upcoming lectures in advance. All right. So once you're following some educator, then you can see the schedule of that educator completely. All right. So this is unlimited access you get once you are subscribed for Plus. So if you have taken the subscription, these are the subscription charges. For 12 months, you'll have to pay 38,500, and for 24 months, you'll have to pay 56,000. All right. And after 10% discounts, you'll have to pay 34,650 for 1 year and 50,400. So basically, you'll get 10% discount. All right. So use this code and you'll get 10% discount, and these will be your final price. Now, second is iconic subscription. So what is this iconic subscription? In this iconic subscription, you get all the benefits of Plus. Whatever you were getting in Plus, you will get in this iconic subscription. All everything what I've just told you about Plus. All right. Apart from that, you'll get a personal coach who will guide you throughout your preparation for top exams like IIT-JEE Advanced, Main, BITS. All right. So you'll get an expert who will guide you throughout your preparation. All right. Your test analysis will be in a personalized manner. You will be given feedback to improve your time management, exam approach, okay, in a personalized manner. So this is what you get when you take Iconic subscription, and your study planner will be customized to you. Your weekly reviews will be given to you to highlight your progress. All right. So this is additional thing you get in Iconic subscription. Okay. So personal attention you're getting by an expert, and these are the subscription charges: 56,000 for 1 year, and if you take after 10% discount, it will be 50,400. Similarly, 86,000 for 2 years, and after 10% discount, it is going to be 77,400. All right. So these are the price list for. So these are the prices for iconic subscriptions for 12 and 24 months respectively. So I hope it is clear. Now let's begin the session. So as I told you, And yeah, you can download this as Unacademy's learning app. You can download it from Play Store. So now let's begin the session. So as I told you, today we are going to do standard limits. All right. 1 minute. All right. These are standard limits you can directly use in the question. So first is sine x upon x, or you can say sine theta upon theta. When theta, that means x is approaching to 0. All right. So you know this limit is 1. Sine theta upon theta is 1. I'll explain this limit. Hello Rishi. I'll explain this limit in detail. All right. And see, first let's plot the graph. Then I'll tell you what I'm about to tell.
Unacademy. Let's crack it.
All right. 1 minute. So say this is your y-axis and this is your x-axis. All right. So graphically, I'm trying to explain this because we also need to know that sin x upon x is approaching to 1, but from which side, whether it is greater than 1, slightly greater than 1, or less than 1. Okay, so that we will try to understand through graph. See, this is the graph of y is equal to x line. This is the graph of y is equal to x line. It's the angle bisector of the quadrant. All right, this is y is equal to x line. Slope is fixed 1, so always inclined at an angle of 45 degree with positive direction of x-axis, and this is the graph of sin x, right? This is the graph of sin x, like this. So you can see both functions y is equal to sin x as well as y is equal to x are odd functions. Okay, are odd functions. So odd functions means they are symmetric, the graphs are symmetric about origin. So whatever the ratio will be on the right side of origin, the same ratio you will get on the left side. Okay, only the negative sign will come, so negative will get cancelled. All right, right hand side you can see sin x is always less than x. All right, when x is positive, so you can see sin x upon x is less than 1. All right, when x is positive. So when you are close to 0, see at x is equal to 0, sin x and x both have same value, 0. In fact, both have same slope. If you differentiate this function, dy by dx is going to be cos x. All right. So at x is equal to 0, they both have same slope, and this function always have slope is equal to 1, right? But what happens when you go ahead of 0? So suppose you are going positive side of on x-axis, so slightly ahead of origin, then you can see that slope of sin x will decrease, right? Because cos x will value of cos x will become less than 1. All right. So value of cos x will become less than 1, and in this case you can see that value of sin x will be slightly smaller than the value of y is equal to x. Why? Because y is equal to x is increasing with the same rate 1, while the rate of increase of sin x has decreased, right? Because cos x has now become less than 1. So just after origin, sin x comes below y is equal to x line. All right, or you can say sin x, value of sin x becomes lower than the value of x. That's why this ratio sin x upon x is less than 1, not exactly equal to 1. It is slightly less than 1 when you are slightly ahead of origin. All right, so when you say when x is approaching to 0, when x is approaching to 0 plus, this sine x upon x will approach to 1, but actual limit will be 1, but actual value will be, limit is 1, because limit means is that if some function is approaching to 2, that means limit is 2. So that is the meaning of limit. If it is approaching to some number, if it's close to some number, then that is called the limit of that function, right? But here we just want to know that from which side sine x upon x is approaching to 1, from right hand side or from left hand side. And why do we want to know this? Because in some cases you will have to take the greatest integer function or fractional part function of sine x upon x, okay, before calculating the limit. So in those cases, this will be important portion. So I'll tell you those points through questions. All right. Okay, from left hand side also you can see sin x is greater than x when x is negative, but if you divide by x, that inequality will be reversed. Why? Because x is negative. Because x is negative, right? So sin x upon x is less than 1 here also. So basically ratio will remain same. Sin x magnitude wise is less than the magnitude of x, all right? The same magnitude you are getting here. So the ratio will remain same, okay? So you can say that sin x upon x, x approaching to 0 is actually approaching to 1, but from left hand side. So whenever he is asking for the limit of sin x upon x, you need to write 1. But why are we studying this 1 minus? I'll tell you why. Okay. Suppose you need to find the limit of x approaching to 0, greatest integer of sin x upon x. Now question is not sin x upon x, it is greatest integer of sin x upon x, all right? All right, so now we know that sin x upon x is approaching to 1 from left hand side. So this value when x approaching to 1 is 1 minus, all right? We need to take greatest integer, and whatever the value of greatest integer, that will be the limit of sin x upon x greatest integer. So you can see 1 greatest integer of 1 minus greatest integer of some number which is less than 1 will be 0. So this limit is going to be 0. And from both sides, from right hand side and left hand side, we know that sin x upon x will be approaching to 1, but it will be slightly less than 1, right, from lower side of 1, all right? So that's why left hand limit and right hand limit both will be 0. So that is the main question. That was the main part because of which we are understanding this 1 plus or 1 minus, from which side this sin x upon x approaches to 1. So this was one of the way, graphical way to explain it. Second, you can use, I'll tell you more about this limit first of all. Suppose 1 minute, just wait for a minute. Yes. All right. Now see, the another way of explaining this is that you know the expansion of sin x is x minus x cubed by 3 factorial plus x raised to 5 upon 5 factorial and so on, right? Alternate plus minus. So if you write sin x upon x, sin x upon x, this is going to be 1 minus x squared upon 3 factorial plus x raised to 5 upon 5 factorial and so on. If you take minus sign common, then you can write sin x upon x is equal to 1 minus common from second term x squared upon 3 factorial minus x raised to 5 upon 5 factorial and so on. And when x approaches to 0, then highest sum will be of x square, because x raised to 5 will be very, very small, all right, compared to x square. So this quantity you can say, basically, if we need the sign of this quantity, yes, it is approaching to 0, but we want to know whether it is 0 plus or 0 minus, okay? Because if it is smaller than 0, then overall limit will be 1 plus, and if it is more than 0, that means 0 plus, then overall limit will be 1 minus, all right? So you can say this is a positive quantity because it depends on the value of x square. Rest of the terms, x raised to 5, x raised to 7, these terms will be very, very small compared to x square, okay? So it doesn't matter if you subtract x raised to 5 from x square. X square is x square is greater than x raised to 5 when x is very small. When x is very small, all right. So you can see now this limit is 1 minus, okay. It's slightly smaller than 1. It is approaching to 1. Limit is 1, but it's slightly smaller than 1. That means we need to remember that it is whenever we are taking greatest integer, then it will work. Then this will help. Otherwise there's no point. Otherwise, see, if I ask you the limit, I'll give you some examples, okay. If I ask you the limit, do not get confused. If I ask you the limit of sine 2x upon x, all right, limit x is approaching to 0, see what will happen. So whenever you have sine theta upon theta and theta approaches to 0, you need to write 1, okay, if there's no greatest integer or fractional part. Then forget about 1 minus or 1 plus. You can directly use 1. So in this case, theta is 2x, but in denominator you have x, not 2x, all right. So first of all, you need to make this theta same in the denominator also. So it should be 2x. That means you need to multiply and divide by 2. Now limit x is approaching to 0, all right. So now you can write this sine theta upon theta, because theta 2x is approaching to 0 when x approaches to 0. So the sine theta upon theta will become 1 and this limit is 2. All right. So this limit is 2. You can write this limit is equal to 2. So I hope you have got it. Now see example number 2. If you have sine of say x square upon x, okay, x approaching to 0, see what will be the answer of this. Now in this case, theta is x square, right? So you need to multiply and divide by x. So it will be sine of x square upon x square. So now you can see this limit x is approaching to 0, this limit is approaching to 0, and this limit is approaching to 1. So it is nothing but 0 into 1, and 0 into 1 is nothing but 0. So that is going to be the answer. I hope it is clear. All right. Now see example number 3. Now suppose you have greatest integer of sine of 5x upon x. Now see, limit x is approaching to 0. Okay. Now let's see what happens. So first of all, sine theta upon theta we need to make. So this numerator is 5x, angle is 5x. So you need to multiply and divide by 5. So it is going to be sine 5x divided by 5x. X is approaching to 0. Now you can see that angle theta is 5x and theta is approaching to 0. 5x is approaching to 0 because x is approaching to 0. So we know that 5x upon x, here you have greatest integer. So you need to be careful. Now we will put first of all 1 plus or 1 minus, whatever we have studied. So basically this limit was 1 minus. 1 minus means 1 minus delta. For clarity, you can write 1 minus delta where delta is very small, all right. So next step you can write delta approaching to 0. As you know, you have put the limit. So now it is in terms of delta. So you can write delta is very small quantity. Delta is approaching to 0 and it is 5 minus 5 delta. So as delta is approaching to 0, so 5 delta will also approach to 0. So this quantity is basically smaller than 5, slightly smaller than 5, all right. And you need to take greatest integer of that. So that will become 4. So greatest integer of some number, or you can say 5 minus is nothing but 4. I hope it is clear. Have you got this? So I'll give you one question. You guys can try this. Sin x of 2x upon minus x, greatest integer, limit x is approaching to 0. Try this. This is a very good question. Try this one. Hi Vamsi, how are you? Oh, good, great. Oh, actually, yeah, I was not well for last few days, so I was having, you can see I still have some cold, and that's why I was not keeping lectures. All right, so now let's do it. Are you getting any answer? Have you got any answer? Write in the comment box if you have got any answer, Vamsi or Rishi. Okay, I'll solve it. You're getting -2. All right, let's see. So now you can see that angle is 2x. So you need to make 2x, write this minus with 2 and divided by 2x. Okay, write like this. As we did in the previous question also, sine theta upon theta is 1 minus delta. So in this also always use 1 minus delta whenever you have some numbers like this -2, 5 or yeah. So in next step you can put the limit of x is equal to 0 and write the limit in terms of delta. So -2, it is going to be 1 minus delta, right? We know that it is 1 minus delta and delta is very small. So now this is your new question. After that, you need to multiply it. So it is going to be plus -2 plus 2 delta, right? So -2 plus delta is basically between -2 and -1. -2 is this, and this is -1. -2 plus delta will be somewhere here. -2 plus 2 delta, right? So greatest unit of that is basically -2. So yes, your answer was correct. Very good. Delta approaching to 0. So this is going to be -2, right? So in this case, my answer will be -2. So this is these are the questions in which it is required to know the limit of sine x upon x precisely, where how this limit is 1. I mean how this approaches to 1 from left hand side or right hand side. Okay, so that was sine x upon x. Now second standard form is sine inverse x upon x. Okay, sine inverse x upon x. So now it's an inverse function, limit x approaching to 0. So actually this limit is also 1. That means sine inverse x upon x also approaches to 1. But again the same question arises, how this limit is approaching to 1. I mean from which side it is approaching to 1. From right hand side or left hand side, or maybe right hand limit approaches to from right hand side or left hand limit approaches from left hand side. That might happen. Okay, so we'll see. So again I'll make the graph first. So you can see sine inverse is the sine inverse x is inverse of sine x. So graph of sine x and sine inverse x are basically mirror image of each other about y is equal to x line. Do you remember that? Yeah, so we are going to use it, okay? We are going to use it and this will help us to understand the limit easily. So again, this is y is equal to x line. This is y is equal to x line. Now, see, this was sine x. This was your sine x. We just plotted sine x in the previous slide. And it was touching y is equal to x line at origin, right? Y is equal to x line is tangent to this curve. Now you need to take the reflection. So if you take the reflection of this part only, okay, only of this part. So that is going to be like this. This is going to be your sine inverse, right? So sine inverse. Yeah. So this is your sine inverse. This point is pi by 2 and minus pi by 2. So again, the sine inverse x will also touch y is equal to x line. Sine inverse x will touch y is equal to x line. One minute. All right. But now you can see sine inverse x is slightly greater than y is equal to x line, right? So this limit, easily you can answer this. Sine inverse x upon x will be slightly more than 1, right? And this will also touch y is equal to x line. So they both have same values at x is equal to 0. And just right side or left side of 0, values will be almost same. But right hand side, you can say sine inverse x will Sine inverse x will be greater than x when x is positive. So you can see sine inverse x upon x will be greater than 1, right? So right side, just right side of 0, it will be almost 1, but it will be 1 plus, all right? Similarly, left hand side, you can see sine inverse x is less than x when x is less than 0. But when you divide by x, so because x is negative, inequality will be reversed. So you can see this ratio sine inverse x upon x will be greater than 1 again, okay? Greater than 1. So left side and right side, both side it approaches to 1, but from right hand side. So now precisely you can write sine inverse x upon x. This limit is 1. This limit is 1, but what you need to remember is that it is slightly more than 1, okay? So this will help us in questions where we have greatest India fractional part functions, all right? So whenever it is required to know whether this approaches to 1 from right side or left side, okay? So in such cases, we will immediately use this limit as 1 plus, all right? It is 1 plus. There's another way of doing it apart from graph. See, you could do one more thing in this function, sine inverse x upon x, x approaching to 0. If you put x is equal to sine theta, x को, if you put x is equal to sine theta, then for x approaching to 0, sine theta will approaching to 0 and theta will also approach to 0, right? This is called change of limit, all right? So we are changing the limit. So if we are changing the limit from x to theta by substituting we are replacing x by sine theta. So after this substitution, we will get sine inverse of sine theta upon x is sine theta, so it is going to be sine theta when theta approaches to 0. So now you can say it is going to be theta upon sine theta. Limit theta is approaching to 0. So now you know that theta is slightly, so you can use previous information which I have given about sine theta and theta. Theta is slightly greater than sine theta when theta is positive. So this ratio theta upon sine theta will be 1 plus, because sine theta upon theta was less than 1. So theta upon sine theta will be greater than 1 when theta is not equal to 0, right? So when we are close to 0, this ratio will be 1 plus. It will be close to 1, but it will be 1 plus. So I hope it is clear. So you need to use that sine inverse x upon x. So let me ask you some questions based on this. Try to find out the answers. These are greatest India functions in second and third. In second example and third example, these are greatest India functions. So we need to figure out the answers of these two. All right, so let's discuss it. So first of all, sine inverse of sine x upon sine x, it is going to be 1. There is no greatest in here. So sine inverse of x upon x should be 1 if x approaches to 0. So you can see sine x is approaching to 0. This is approaching to 0. And argument and denominator are same. So this limit is going to be 1. Okay. In this case, you don't need to write 1 plus or 1 minus. Directly you can use this limit is equal to 1. All right. So I hope it is clear. Now next one. Now because it is greatest in here, before taking the limit. So now in this case, you will have to use that 1 plus or 1 minus. Okay. You need to know it precisely whether it is 1 plus or 1 minus. So if it is sine inverse of 4x, so you need to make 4x in denominator also. So sine inverse of 4x upon 4x, first write this and multiply it by 4. Okay. And x is approaching to 0. So what we have studied, that sine inverse of x upon x when x approaches to 0 is 1 plus. So in this 4x approaches to 0 because x approaches to 0, or 4x they are same. So yes, you can write this as 4 times of 1 plus delta. Okay, 1 plus delta, use that. 1 plus means 1 plus something very small. So delta is approaching to 0. That is your question now. So if you see that this is nothing but 4 plus 4 delta, and from 4 plus 4 delta, this 4 delta is again very small, so it is basically 4 plus, right? So it is 4 plus, and greatest integer of 4 plus is nothing but 4. So that is your answer. I hope it is clear. Now the third one you can see is sine inverse of minus x square divided by, now you need to make minus x square approaches to 0. Okay, and it doesn't matter whether it is approaching from left hand side or right hand side, because minus x square will always be negative. It should approach to 0. Sine inverse x upon x will be 1 plus. All right, whether x approaches 0 from left hand side or right hand side, it doesn't matter. All right, so sine inverse of minus x square upon minus x square, you just put this minus and put this minus here also in numerator. All right, minus 1. Now x approaches to 0. So this limit is going to be 1 plus. All right, so 1 plus. So it is minus 1 into 1 plus delta. All right, 1 plus delta. Now this will help in negative. Whenever you have a negative quantity in multiplication, then writing 1 plus delta will help a lot. So now it is minus 1 minus delta. Now you can see this limit is actually smaller than -1. This number is smaller than -1, all right? So it is between -1 and -2, you can say, all right? So because it is between -1 and -2, so its greatest area will be not -1, it will be -2, okay? So if number is between -1 and -2, its greatest area will be -2. So I hope you have done it correctly. Now let's move to another limit, third limit, which is limit x approaching to 0 tan x upon x. All right. So this limit is also one standard limit. You can use it anywhere. But again, we need to know that whether how does this approaches to 1, from right hand side or from left hand side. Okay. So for that you need to know the graph first of all. So I'll plot the graph. I'll explain in the same way, the way I have explained sin x upon x. So you need to compare the graphs of tan x and x, y is equal to tan x and y is equal to x. Okay, and it's very simple, easy to compare. This is y is equal to x line. All right, this is the graph of tan x, comes from infinity, and it is like at x is equal to 0, it will be 0, and its slope at 0 is 1, so that means it is tangential to y is equal to x, but it is slightly above y is equal to x line when x is 0 plus, that means right side of 0, and below this line, because both are odd functions, so graphs will be reflections of each other about origin. All right, so graphs are basically mirror image of graphs are symmetric about origin. So now this side you can see this is y is equal to tan x. If I ask you y dash, then that will be sec square, and you can explain the behavior of tan x, why tan x is above this y is equal to x line. You can see at x is equal to 0, uh, slope of y is equal to x is 1, this is fixed, right? This always 1, and slope of y dash, slope of y is equal to tan x is sec square. So at x is equal to 0, sec 0 is 1, so it is 1. That means both have same slope, same value, so they touch each other, all right? Y is equal to x and y is equal to tan x. So y is equal to tan x is tangent to y is equal to tan x curve, right? Y is equal to x line is tangent to this curve. But as x is more than 0 or less than 0, around 0, right? Sec square will be more than 1. Sec is cos is less than 1 and sec square will be more than 1. Sec square is more than 1, that means the rate of increase of tan x is now greater than the rate of increase of x. So now it is tan x is rate of increase of tan is more than the rate of increase of x. That means tan x will be faster. Value of tan x will be greater than the value of x because it is increasing with a higher speed. All right. So as you go right side of origin, then tan x will be slightly more than, all right, slightly more than x. So you can see tan x is greater than x. Tan x is greater than x when x is more than 0. So you can say tan x upon x will be more than 1, all right? So when you are looking the value of tan x upon x on the right side of 0, it will be slightly more than 1. So it is approaching to 1, but this is 1 plus, right? And left hand side, they will remain same. Left hand side, not tan x is less than 1, tan x is less than x. But if you take the ratio, if you divide by x, x is negative, so this inequality will be reversed, so tan x upon x will be more than 1. So magnitude wise tan is greater, right? Whether it is right side of 0 or left side of 0. So left side of 0 both are negative, magnitude wise tan is greater, so minus minus anyways will get cancelled and magnitude will matter, okay? So magnitude of tan is greater, so tan x upon x will be more than 1. So this is what you need to remember. Limit x approaching to 0, tan x upon x, all right, is equal to 1 plus, all right? And you know, where are we going to use this? Whenever we have greatest linear function, fractional part function. So in all such questions, we'll use it, okay? So I'll give you some questions. Um, let's take one example. What is the answer of this? Sorry. What is the answer of this? So you can see it is going to be tan of theta is 3x. So make 3x in denominator also, 3x, and 3 will be multiplied. So now you can see this limit is 1. And because there's no greatest thing or fractional part, so whether you write 1 plus or 1, they are same. So ultimately you need to write 3 into 1 plus. 1 plus is close to 1, so it is 3 plus 3 plus means 3. It is approaching to 3. So tan 3x upon this 3 plus is not a proper way of writing, it's just to understand, okay? Remember that 1 plus is you will never see 1 plus. Whenever 1 plus is written, that means he's talking about the right side values of 1, okay? So answer will always be given like this, that limit is approaching to 3, okay? A fixed number, a finite number. So it is a fixed number 3, and this limit is approaching to 3. So I hope it is clear. I'll tell you another example. So I'll give you some examples to solve these examples and find the value. So what is the answer of this? Greatest India function, okay? So now I'm putting greatest India function. First term, try these questions. Right? Try these sums. Try to find the answer. Limit x is approaching to 0 in all the questions. Limit is approaching to 0. Okay, so try these sums and try to find the value. Take care of these numbers and negative sign also in second question. Use that 1 plus delta 1 minus delta. All right, so let's do the first one. It is tan 4x divided by, you need to multiply and divide by 4 so that angle will become same, so tan theta upon theta. All right, and x is approaching to 0. Now tan theta upon theta is 1 plus, so you need to write 1 plus. All right, so if you write this as 4 into 1 plus, or you can use 1 plus delta. So 1 plus delta multiplied to 4 is nothing but 4 plus, okay? That you can write easily. Whenever you have negative sign, then just write everything in detail. So greatest integer of 4 plus is nothing but 4. Okay? 4 plus means slightly greater than 4. So greatest integer of 4 is 4 plus is 4. Now in this case, there's a minus sign. So tan of minus 4x is also approaching to 0. All right, so just make minus 4 in denominator also, minus 4 and minus 4. And greatest integer of this, x is approaching to 0. Now like previous question, in this also you need to write 1 plus. But in this case, write 1 plus delta. It's better way, 1 plus delta. Otherwise, answer might be wrong, Students do mistake in this, that's why I'm telling you. So delta approaching to 0. Now you see, it will be, if you multiply minus 4, it is minus 4 delta. So actually it is smaller than minus 4. It is smaller than minus 4, or you can say it is between minus 4 and minus 5. It is somewhere here, right? Minus 4 delta. Minus 4 delta. Close to minus 4, but smaller than minus 4. So greatest integer of that is going to be what? Minus 5. Okay, that's why I'm telling you to be careful in this question. I hope it is clear. Now let's see limit of sine 4x upon sine 2x. What is the limit of this? So in this case, you can write this is equal to sine 4x upon 4x, all right, like this. And you need to multiply by 4x also. And similarly, you can write 2x upon tan 2x. You have to divide by 2x also. This x and x will get cancelled, all right. So now you see this limit is 1 minus, this limit is 1 minus again, because tan. Okay, tan theta 1 theta you can write in denominator. So you can write like this, 2 into this is 1 minus. In denominator, if you take this 2x in the denominator of tan 2x upon 2x is 1 plus, okay. So if you divide a number which is less than, okay, so if you divide 1 minus, that means number which is smaller than 1, divided by number which is more than 1. So this ratio will be less than 1 only, right? Because denominator is greater than the numerator. Leave this 2 aside, okay? Leave this 2 aside. So you can write this as 2 into, ultimately it is 1 plus, right? That means slightly more than 1. My greatest integer of that. So number which is, if you multiply 1 to 2, it will be 2. If you multiply number more than 1 to 2, it will be more than 2, right? So it is 2 plus. And greatest integer of 2 plus is nothing but 2. So answer is 2. So I hope you have got it. So in this we can solve these problems. Now I'll give you slightly better problems, okay? Let's bring some more twist in this. Now suppose you have sine of greatest integer, sorry, greatest integer of sine of mod of x upon x. All right, this thing. X is approaching to 0. Try to figure out this question. All right. Second is so try to answer these two questions. Okay, sine of mod of x upon x. Let's see. Uh, if you in this case, because you have mod on x, so you'll have to find right hand and left hand limit separately, all right? So let's see right hand limit. Right hand limit when x approaches to 0 plus. So you need to plus 0 plus h in this. So you can put x is equal to 0 plus h, and h approaches to 0 will be the limit, all right? And the h is always positive. So h approaches to 0, you need to put 0 plus h, that means sine of mod of h upon h, all right? So mod of h is, because h is a positive quantity, so sine of h is a positive quantity, sine of mod of h can be written as h. So it is going to be sine of h divided by h, all right? Greatest integer. H is approaching to 0. Sine of h upon h is 1 minus, so it is going to be 1 minus h is approaching to 0, and this limit is going to be 0. I hope it is clear. Now let's see left hand limit. What is this? So left hand limit is, now you need to put 0 minus h, so h approaching to 0, and this is sine of mod of minus h divided by minus h, all right? So mod of minus h is nothing but h sine of, so it is sine of h because h is a positive quantity. So mod of minus h will become h, but this minus will remain there in the denominator, all right? So now, as I told you, whenever you have minus sign, just be careful. Do not write 1 plus 1 minus. Write 1 plus delta or 1 minus delta. So you can write delta approaching to 0. This is minus of 1 minus delta, all right? 1 minus delta. Now this 1 minus delta, if you take this minus inside, it is going to be minus 1 plus delta. Minus 1 plus delta is basically slightly more than minus 1. That means it is between minus 1 and 0. So its greatest integer is going to be delta and h. These are positive quantities. Minus 1 plus delta is between minus 1 and 0. So its greatest integer is going to be minus 1. All right. So right hand limit is 0 and left hand limit is minus 1. So limit does not exist. All right. So does not exist. Very true. True, Vamsi. Now similarly, you can find the limit of tan of mod of x upon x. So try this one. Limit of tan of mod of x upon x. All right. So in this case also, let's first of all. So right hand limit when h approaches to 0, it is going to be tan of h upon h. All right. And this is nothing but 1 plus, and 1 plus is nothing but 1. Okay. So this is right hand limit. In left hand limit, h approaching to 0, greatest integer of tan of minus h mod divided by minus h, greatest integer. Now it is going to be minus of tan of h upon h. This denominator, minus sign in denominator will be remaining, h approaching to 0. Now you need to, because you have got minus sign here, so you need to put 1, not 1 plus, 1 plus delta, right? 1 plus delta. So delta approaching to 0, and delta is a positive number, okay? Delta and h. whenever you put delta as a positive number. So this is minus 1 into 1 plus delta. So if you see, this is nothing but minus 1 minus delta. So it is between minus 1 and minus 2, right? Slightly lower than minus 1. So greatest linear of that is going to be minus 2, all right? So right hand limit is 1, left hand limit is minus 2. So limit does not exist. Limit. So I hope these things are clear. Now there are some more standard limits like exponential tan inverse and tan inverse x upon x, e raised to x minus 1 upon x, 1 plus ln x upon x. So three standard limits we have covered in this portion. I'll bring another part 2 of standard limits, in which we'll discuss remaining 3 standard limits, all right, in which we can put greatest linear, and then we will have a practice session including all the 6 limits, all right, all the 6 limits. So this is a very interesting portion. We'll continue that. I hope you have enjoyed it. All right, so thank you very much.